Assalamu alaikum warahmatullah. Hi everyone, this is Mr. Abdullah Faris. In this video I will be working on question 16 from the coverage of a grade 12 elite for term 1. So question 16 has a couple of suggested questions for the final exam. So let's see some of them. The first question, we are given 3 line segments and a semicircle for the graph of f, and we are given also g of x, which is defined as the definite integral from -2 to x f of t dt. There are 4 parts to answer. The first part is find g of -6 and g of 3. We are given g of x, we just need to find g of -6 and g of 3 by replacing x with -6 and again with 3. So the first part, we have g of -6, which is equal to the integral from -2 to -6 f of t dt. Notice that the upper bound is smaller than the lower bound, so we can multiply by a negative and flip the boundaries of the integral. That means -6 is down, -2 on top, f of t dt. Now this definite integral means the area under the curve f from -6 to -2. So basically we are finding the area of this triangle. So this is equal to minus, and then the formula is half times the base is 4, and the height is 5, that is going to be -10. Now repeat the same process for g of 3, that means we are finding the definite integral from -2 to 3 f of t dt. And we are now interested in the area from -2 all the way until we reach 3. So we have 2 portions. The first one is a semicircle and the second one is a triangle. So let's find the area of each of them. The first one is above the x-axis, so it's positive, so it's half times 5 times the radius squared, the radius is 2. Plus, now the second area is under the x-axis, so it's -half times the base is 1 and the height is 2 units, so that gives 2 squared is 4 over 2, 2 pi minus 1. Now this is part A. Now, if you look at part B, part B says find g prime of 0. You need to find g prime of x first by differentiating this function. Differentiating this function gives you g prime of x equals f of x. This x goes in here and the integral cancels. So g prime of 0 is equal to f of 0, and from the graph, what f of 0? F of 0 is equal to 2 from the graph. Hope everything is clear so far. Now if we look at part C says find all the values of x on the open interval from -6 to 3 for which the graph of g has a horizontal tangent, and then determine whether g has a local maximum, minimum, or neither at each of these values. Justify your answers. Now, g prime or g has a horizontal tangent. It means that g prime of x equals to 0. And notice that this is the graph of f, and at the same time it is the graph of g prime. So g prime equals 0 at 3 points. The first one is -6, -2, and 2, but minus 6 is not included as the question says open interval. So there are two x values at x equals minus 2 and at x equals 2. At x equals minus 2, g prime does not change sign. G prime before minus 2 it was above the x-axis, and after minus 2 it's still above the x-axis. So at x equals minus 2 we say what? We say neither. Why do we say neither? Because g prime of x, which is the same as f of x, does not change sign. Now, what about the other point? X equals 2. At x equals 2, just before x equals 2, g prime is positive, means above the x-axis. And after 2, g prime is negative. That means at x equals 2, we have a local maximum So at x equals 2, there is a local maximum because g prime of x, which is the same as f of x, it changes sign from positive to negative. Positive means above the x-axis, negative means below the x-axis. So, the last part of this question says find all values of x on the open interval for which the graph of g has a point of inflection. A point of inflection happens when g double prime, it changes sign. And we know that g prime of x equals f of x. That means g double prime of x is equal to f prime of x by differentiating both sides. Now, if you look at the graph, just let me erase what we have done here. So here f prime, which is the slope of the tangent line, was positive. F prime is positive. And here f prime is negative. Now here on this portion, f prime is positive, but at this portion, f prime is negative. So, f prime, which is the same as g double prime, it changes sign at 3 points. The first one, x equals minus 4. The second one, x equals minus 2. And then the third one, x equals 0. Again, the graph of f is increasing, that means f prime is positive here. Okay, so it's increasing. I'm talking about f. If f is increasing, f prime is positive. and after this point f prime is negative, and we know that f prime is the same as g double prime. So g double prime here is positive, right? And after this point, g double prime is negative. Follow the same analysis for the rest of the points. So at these 3 points, what happens? We know that at x equals minus 4, g double prime of x, which is the same as f prime of x, changes sign from positive to negative. At x equals minus 2, g double prime of x, which is the same as f prime of x, it changes sign from negative to positive. And repeat the same explanation for x equals minus 4. This explanation is the same for x equals 0. There is another explanation. You can say that g prime changes from increasing to decreasing or decreasing to increasing. So you can have a look at the answer key. But this is going to be enough. If you write g double prime, which is the same as f prime, it changes sign from positive to negative or negative to positive. That's all for the first question. I wish you all the best. See you in the next video.